For the device to be able to send data to the server, we have to configure the device with the correct APN and fill in the server settings. All of this is configured in the GPRS tab that we are going to go through today. The very first section you will see in this menu is GPRS settings. In here, we are able to configure multiple settings, including the APN. The GPRS context allows us to disable or enable GPRS connectivity. It is useful if you would want to use the device as a black box, where device would not connect to the server in order to transmit data, but rather keep it in the internal memory of the device so it could be extracted in case it is needed. Other three fields here are dedicated for the APN, APN username, and APN password. This information should always be provided by your SIM card provider. It is common for the device to have GPRS connectivity issues due to incorrectly entered APN, so in case you are having any issues with the data sending, it is recommended to double-check the APN field and confirm the entered value is correct. A new setting introduced in the 29th branch base firmware is Limit Connection Errors setting. If this limit is enabled, the device will implement delays to GPRS connection retries, as without it, the operator could ban the device from his network for some time, causing delays in data sending. Why the device might try to open a GPRS context multiple times. It usually happens due to the low signal, which does not allow the device to reliably communicate with the operator and the server, which causes the device to try and open the link over and over again. Finally, we have the GPRS authentication setting, where we can select which authorization type should be used when connecting to the operator. By default, it is set to PAP, but the exact setting here should be provided by your mobile operator together with the APN settings. Next setting I would like to speak about is Auto APN. This feature allows the device to automatically find the correct APN based on the operator code. The Auto APN works together with the APN file, which is basically a collection of various APNs, and the operator codes which use them. The file is uploaded in the manufacturing, so if you would want to add your operator APN to this list, please reach out to us via Help Desk system, and we will be able to add your APN to this list. However, it is important to note that we recommend using Auto APN only for the first connection to FOTA WEB. When preparing the configuration for the device, Auto APN should be disabled, and we should enter the APN provided by the operator manually. Moving to the server settings, here we can configure the server domain, IP, and port. This information should be provided to you by your platform provider. Next, we just need to select the communication protocol that will be used for communicating with the server. We can select TCP, UDP, or MQTT. The TCP and UDP protocols are used in regular Codec 8 and Codec 8 extended servers, while MQTT allows us to send data to Microsoft Azure or Amazon Web Services IoT hubs. Finally, we can select if we want to encrypt the data that is sent to the server using TLS encryption. Encryption will only work if the server receiving the data is able to decrypt TLS encryption, so if you would like to use this feature, contact your platform provider to make sure it has already been implemented on their side. If server supports this functionality, all you need to do is upload the certificate in the Security tab or using FOTA WEB system and the platform that is receiving the data. Moving to the next group of settings, we find second server settings. Here, we can configure secondary server, where the data would be sent in a case of main server not being available, or if we just want to duplicate the data on two servers at the same time. First, we need to select the backup server mode. As I mentioned, here we can select backup or duplicate mode, depending on the user need. We also see EGTS setting here, but it is a communication protocol which was implemented for one of our clients and is not used anymore, so we are not going to get into this setting any further. As for the backup mode, it works exactly how it states in the name. In case the main server fails, it works as a backup, so it could receive all of the data from the device and the user would have some redundancy. The duplicate mode simply duplicates the data that is sent to the main server and forwards it to the secondary server. It is most often used for troubleshooting purposes when we want to see if the issue is caused by the server or the device. Please keep in mind that with any one of these modes selected, the data will be kept inside the device internal memory until it is sent and received by both servers. This is especially important for duplicate server mode, as often people just delete the device from their platform without making any changes to the device configuration, causing the device memory to get overfilled, after which some of the device functions could get affected. After we select the backup server mode, the rest of secondary server configuration is the same as with the main one. We need to specify the domain, IP, port, and communication protocol. If needed, we can also enable TLS encryption for the second server. Another setting group we can find in the GPRS Settings tab is Record Settings. Here we can specify how the device will communicate with the server and how it will control the GPRS connection. The Open Link Timeout setting allows us to configure the time. Device will try to stay connected to the server after all records are sent. This timeout is useful if the mobile operator is charging users per link activations, that way limiting the amount of times device will connect and disconnect from the server. Additionally, longer timeout is useful if we want to reach the device using GPRS commands, as they are only accepted after all records are already sent to the server. The downside of increasing this timeout is that the device will not be able to enter sleep mode if the link with the server is not closed. Response timeout determines how long the device will wait for a response from the server before disconnecting. This setting is important if we have backup server configured, as only if the timeout elapses for the main server, it will try to connect to the backup server. Third setting we have is the network ping timeout, which is used together with the open link timeout. Sometimes the operator refuses to keep an open link between the device and the server when there is no data being transmitted, because keeping the link open adds additional load on their infrastructure. To battle this, network ping timeout was introduced, which will send a 1-byte long packet to the server, this way simulating an active link, which operator cannot close. The time set here defines how often this packet will be sent to the server. In this section, we also configure the device record sorting logic when the records are sent to the server. If we select Newest, the record that was generated last will be the first one to be sent out. If we select Oldest, the device will first send all of the records from the memory and only then will begin sending current data. This setting is especially important for users who want to have live tracking solution, because in that case, the newest records should always be sent first, so we would have the newest possible position information. However, this could lead to jumps be visible on the track until all the records are sent to the server and tracking information is updated. Finally, ACK type setting determines what method the device uses to receive confirmation from the server, TCP/IP or AVL. TCP/IP means that the confirmation will be included in the TCP/IP layer and no additional message will be needed, while AVL means that the device will expect an additional AVL message from the server. Final section in the GPRS window is FOTA WEB settings. Here we can configure how often the device will connect to FOTA WEB or disable the FOTA WEB feature altogether. Please keep in mind that if the FOTA WEB status is set to disabled, such configuration cannot be uploaded via FOTA WEB due to security purposes. As for the domain and port, we recommend leaving the default values here, as it allows our device to connect to the FOTA WEB server. The default connection period is 12 hours, meaning that the device will connect to FOTA WEB 2 times per day to check if there are any pending tasks waiting for it. If needed, this timer can be decreased to as low as 30 minutes, but with a downside of increased data consumption.